Good evening and afternoon, friends. Welcome to another session of this ASCII ADBI leadership course on citywide CVS leadership and CVS development. Big long name. So today's it's a kind of a different kind of a session where we'll be talking specifically on fecal sludge treatment, and it'll be kind of an exhibition where our concessionaires, people who are actually practicing in the fields, they would be talking to us, they would be showing to us what they have done, how they have implemented, and what are the technologies, how they have put those technologies together, and then come up with this fecal sludge treatment plant. To begin with, I would actually take the session. I would initially introduce you to the different people who would be speaking about different kinds of technologies. And then I would just try to brief you what the principal objective of going through this fecal sludge treatment is in a very short kind of a context. And then we will welcome one after the other, the speakers, and then we'll go through. Surprisingly, I would like to share here that the speakers we have today, or the entrepreneurs we have today, most of them are not qualified. By their qualification, they are all not absolutely into wastewater, qualified with wastewater business or wastewater technicalities. As I read through them, as I introduce you, you will you'll see that they belong to a myriad of qualifications, but it's just out of their passion to work in the field, to bring out a kind of a change into the environment and to the society, that they have taken up this kind of a work. Let me begin with Mrs. Namita Banka. Namita Banka, she is a science graduate from Delhi and then has a postgraduate diploma in jewelry designing and is a manufacturing mentor and advisor to many enterprises. She is the founder of Banka Biolu Limited, which is a research-driven, publicly listed enterprise engaged in developing environmental friendly water, sanitation, and hygiene infrastructure and services. She's the first woman, perhaps, in the country, and has been recognized and awarded for her business model and innovation. She was conferred the Udayami Award by Shri Venkaiah Naidu, the Vice President of India, back in 2018. She's a recipient of the Cartier Award of 2030, to name. Let's listen to about Professor Srikant Mutnuri, a qualified botanist, focuses his work on sustainable development goals with major emphasis on clean water, sanitation, affordable clean energy, climate action, etc. As a part of the Global Sanitation Graduate School, he offers ME in Sanitation Sciences, MTech in Sanitation Science and Technology, Management, Working Professional, minor programs in Water Sanitation Engineering, and guides several number of students in this topic. But other than being an academician and researcher, he is also a business startup which provides solutions and services in liquid and solid waste management. To his credit, he has Sustainable Biosolutions, to his credit, Backtreat by Environmental Solutions, to his credit, and he also works with Zycon Biosciences Private Limited, which focuses on enzyme production and purification. Our next speaker for the day is Mr. K. Srinivasa Rao, who is a chemical engineer of more than 17 years of professional experience in pharmaceutical and biotech industries, having executed EPC projects all around in India in water and wastewater treatment, sludge and solid waste management, soil restoration projects, eco-friendly, energy efficient projects. He's the founder and the managing director of companies like Meliorate Engineers Private Limited, Meliorate Trident, JV Private Limited, VGMS Infra Private Limited, Vector Meliorate Private Limited, and also is also the director of Pristine Bharat Infra Private Limited. The next speaker for the day we come up with as Mr. Anand Kumar, an electronics and communication engineer by qualification, and having worked for several years in industries like building automation, factory automation, solar power plants, wastewater treatment. For the last 7 years, he's become built up as an entrepreneur and is the director of Dinery Engineering Private Limited, and again works specifically on these kind of projects of fecal sludge treatment plants. And our last but not the least speaker of the day is Mr. Ajit Oak from Primove. Again, a civil engineer graduate with more than 25 years of professional experience in urban and rural infrastructure projects, mainly in water supply, sanitation, water resource development, roads and buildings. He has rich experience in assessment, design, construction, supervision, rehabilitation, extension, operation, and maintenance of community-based projects covering rural infrastructure projects like water supply and sanitation, resource development, irrigation, watershed management, etc. Today, he would be speaking of a very unique kind of a water treatment process where he would be talking about tiger biotoilets, where he would be talking about wastewater treatment through worms. Something unique. And so every other exhibit today you have something new to learn, something new to see, something new to absorb through. Before I ask the speakers of the day today to come up and give up their presentation, I would request Jyotsna to please pull on the slide deck just to give you a kind of what exactly this fecal sludge treatment should be thought of, how we should be thinking of. So something to say about that fecal sludge treatment plant. When we talk of design and operations of fecal sludge treatment plant, there are certain objectives and certain outputs we look into. Based on the outputs we look into, we set up, an objective and the outputs we look into. In between, we actually set up different kinds of technologies. The next slide, please. So what do we do? Our prime objective, as we have been discussing in the past few sessions when I spoke about the characteristics of fecal sludge, yesterday when we talked about gray water, wastewater, black water, we talked that this fecal sludge, one of the prime thing it contains is organic load, a huge amount of organic load, which is of the highest priority when we are thinking of designing a fecal sludge treatment plant. Whether it is in the sludge, when we need to reduce the organic load. Then comes of prime importance is the pathogen removal from the outputs which are coming out from the FSGP or fecal sludge treatment plant, and then finding out ways or looking for ways where the outputs of these FSGPs can be reused, recirculated, or given back to the environment. It's something which has come from the environment, it can be given back to the environment. But to that, we need to ensure that the organic load has come down, the pathogen removal is absolutely not there. Pathogen has been removed so that it can be given back to the earth, again, for some kind of a productivity. The next slide. So these are some of the things we look into. On the performance, we look into the water and the solids, whether they, on a technical side, we'll try to look into whether they are meeting the discharge norms or the reuse standards. At the local context, we look into the characteristics of the sludge, and then we think about the dewaterability, based on the solids concentration and the stabilization, we design the kind of dewatering mechanism, at what frequency a particular treatment plant would receive it, and how much time will it take to completely treat after it receives a load. If the treatment system that has been put up is robust enough to take up all the climate changes. Is land availability, we know in urban context, is quite a challenge. So how much of the land footprint would be required for a plant? And finally, as I said, what would be the end use? How will I use it? What will I do with it? That should be the ultimate goal of my thinking when I'm designing a fecal sludge treatment plant. Talking of the O&M requirements, how much of my human power, human resources required, what will be my cost, and then how much of the skill set each of these persons working in this treatment plant would be requiring. And then finally, of course, comes the investments, the O&M costs, and the affordability for the households and the ULB to bring in that sludge into that plant and that make the plant functional. The next slide, please. So to talk of, the process is very simple. Let's put it very simple. is like when a raw septage or it comes, we take it in a receiving chamber. I'm going from my left to the right, if I say, in the slide, if you see. So from the raw sludge, we receive it in a receiving chamber, because we'll be receiving it in different loads, different trucks will come, and then we can actually homogenize it. And when it goes through, and then when it passes through, there should be a screening. Just a few seconds back, when you were watching the videos, you were seeing that there was a kind of a screening where these sanitary napkins or these kind of plastics, all these should be screened out. The grid should be removed. And then a kind of principal part of this fecal sludge treatment comes up is the solids liquid separation, or as we call the dewatering part of it. Every process today, you will see this will be the general flow sheet that will follow. That there will be a kind of receiving, screening, and then there will be a solid liquid separation. And after the solids and liquids are separate, the liquid will go through a different series of treatment. It could be anaerobic, it could be aerobic, it could be some chemical or anything else. And then the solids separately will again go through a chain of events where they would be concentrated, a moisture content will be brought down, they would be rid free of pathogens, and then so that they can be used up as soil conditioners. That's the basic scheme of whenever we design a kind of fecal sludge treatment plant. The next slide. Now to talk about, as I said, there are several processes we will be discussing today, where there are these settle and thickening tanks, geobags, IMOF tanks. These are some of the techniques we'll be talking of, where it will be they help in these particular kind of units help in the dewatering of it. Post the dewatering, as it comes to the water, treatment of the water. There are several processes. I told there are aerobic processes, there are anaerobic processes. And then when the solids come up, solids need to be treated. As I said, heat drying could be done, composting could be done, vermicomposting could be done. Simple sun drying, but effectively done can be, effectively designed sun drying could be done, so that the pathogen reduction is there in the biosolids. And finally, the dried sludge or the biosolids can be used as building materials, energy, biogas. But in the Indian context, we generally prefer to look into the agricultural context, where it can be used as a soil conditioner or a manure. The next slide. For more additional resources, these are some of the additional resources which are already available. You can go to these sites, or we can also share with you these booklets as a part of our learning management system. You can find them and you can refer to them to get more ideas about it. Having said that, this is what we are going through. I would like to welcome our first speaker of the day, Mrs. Namita Banka. I have already introduced you to her. So I would request Mrs. Namita Banka to please take up the slides and speak. Thank you, ma'am.
Thank you and good afternoon, everybody, for this e-exhibition today. As already I've been introduced, I'll not waste my time on that. Let's go for sharing my screen. Is it visible?
Yeah, it is, ma'am.
Okay, great.
Maybe put it in the slideshow.
Yes, I will do that. Just give me 1 minute. No, I have to stop sharing and then, okay. Yeah, so is it in the full screen? Can you see it in the slide mode, or it is, yeah, now is it okay?
Now.
Yeah, now it's okay.
Yeah, so my, of course, I have 15 minutes. So I have laid out my presentation into some slides. We'll go deep into each of them, and I'll try to cover the maximum in this 15 minutes that I have. Sorry. So first thing is that Rashi has already explained us the treatment objectives and the general processes that we have. and the technologies that's available. So today I'll be talking on a very, very specific technology called geotube dewatering technology. So first I'll explain what geotube means and what happens actually. So geotube is, of course, a non-mechanized, very, very non-mechanized system to effectively separate the liquid and the solid. So our main process or the heart of the system is separation of the liquid and the solid, because the first thing that has to be done in fecal sludge treatment, because of the solid contents are very, very high, organic load is very high, we need to separate the two before we can take up any kind of a further treatment. So when we designed this whole system, and we found that geotube are acting like a very good source separator without using any energy to reduce the organic load by almost 95%, which of course my team still believes it's 95%, but my studies have shown that we can reduce it by 99%. So this is a simple bag kind of technology where the waste is pumped in, and it separates like how we simple do the method of curdling of milk, where we separate the paneer and the liquid. The same concept is applied here, and this technology is been in use across the globe since 100 years. So it's not new, but it has not been used so much in fecal sludge. It was used more for dewatering in mines, in areas where the solids were very, very high. So of course, this is a stage of treatment where the material is received in the first chamber, or we call it a receiving chamber, receiving tank, and then it is homogenized and gone. Solids are separated. Then the primary treatment comes, where we are chemically or organically, cosmetically improving the sludge. Like, when we add this polymer, it separates the liquid and the solid at the primary stage, so that the dewatering becomes very, very effective. So that we do, and then this whole material is passed through the geobag, where effective dewatering happens. Then after the effective dewatering happens, so this is our flow chart. If you see, this is a sludge, and when the water comes in the geotube, it gets separated into two parts. First part is that the solid is retained inside the bag, and the liquid is discharged outside and collected in a tank. So it's collected in the tank. So then after that tank, the water comes out, we take it for treatment, and we are using different methods and different units that we have, where somewhere we are using it aerobically. We have tried SPR, we have tried normal, simple treatment. I'm sorry, you'll have to excuse me for my throat today. So this is what is happening when the water comes out. We have tried different technology, aerobic and mechanical processes to treat, and we have seen that we are getting a very, very good quality of water, which is being reused in our system. And then finally, we pass it through all the ACF, PCF, and filters to use it for our own purposes. And the solid, which is mostly in the bag for more than 6 weeks, is left to dry on the open. So, but we keep pumping the geobag till it gets full. So it takes about 2 to 3 weeks to get filled, and then we leave it for the next 6 to 8 weeks. This is a typical general layout where we have all the office and the pump room and the receiving station, and of course the geotube platforms, which are which occupies the maximum space in the plant. So these are some photographs that we have from live from our sites that we're operating right now. So this is how the tanker comes and deposits the sludge into a screening chamber. This is how if you see the first picture here, the polymer is prepared and it is pumped in line. So we don't have anything separate for when the waste is pumped through the pipe. It is the dosing has been done, And we call it a zigzag or an anaconda kind of design, where the flocculation happens in meanwhile while it is being pumped, and then this whole material is pumped into this geobag, and this is how it looks when it is pumped. So immediately the separation happens, and the effluent, the water comes out, and the solid retains inside. So now we have started, upgraded our SBR secondary treatment. The reason for it, that before we were allowed to, or maybe before the norms were 30 BOD or less, but now since it's the norms have that we have to bring it down to 10, we have installed a simple SBR system, very, very simple SBR system, which helps us to reduce the BOD, COD and maintain it below 10. And it also is able to help us in maintaining the nitrogen levels. This is a simple Pluto. We call it a Pluto. Pluto means small. So most of our treatment capacities are from almost 3 KLD to 50 KLD. It is very, very efficient, very, very economical, and very, very easy to install. It's completely containerized, and we put all the equipments inside this to operate by the operator. You can see this is the quality of water we are able to generate as of date. These are some of the infrastructure. Definitely the projects that we have done is under Telangana government and Andhra government. So they had a requirement of certain kind of infrastructure that has to be built. And as a company, we have always felt that we need to build something very sustainable and green. So we have used CSC bricks in all our construction, which helps us reduce the temperature of the buildings to 4 to 5 degrees. And also it looks very, very nice and more rural. So after the 6 weeks or 8 weeks, when we open up the bags, this is how it looks. The bags, completely dried solids we get. Now this solid, of course, they are in a very hard rock form time. So we pulverize them to a smaller size of 3 mm to 4 mm particles, and we pack it and distribute. Most of it has been distributed till date. We have almost generated 150,000 kgs of these solids, which have been 100% given away for free around the community, because we believe if we are able to develop the community along with what we are doing, it thrives better. And we have also used it in our own plants, where we have grown some kind of vegetables, which are very, very evident. If any one of you visit, you can get first-hand feel of these vegetables and the fruits and other things that we are developing. So the very, very salient feature of this technology is it's very, very scalable. There's no odor at all. The geotubes, of course, is the only, sometimes people do say that is the only constraint, but we feel that that's not a constraint, because something or the other has to be a consumable. So geotube can be resold. We have resold them. Discharge norms are met, can be met very, very easily. And I feel that because the requirement of electricity is so low, that we can install it anywhere, wherever there's a shortage of electricity also. And the operation is simple, where we deploy people and local people locally. We don't generally send it from Hyderabad. Installation time is very, very low. Here in Hyderabad and Telangana, because of so many kinds of infrastructure required, it took us 3 months. Otherwise, if you just don't want all that, we can do it in 1 month to 1.5 months. All this I've already spoken to you. So USP, the biggest part of this technology is the USP. So it can handle incoming septage of any shock loads. That means there is a lot of solid variations that we have seen in last 4 years. So we have seen solids coming as low as 1% to solid coming as 8%. That means that sometimes it's very, very old septage from septic tanks, which we cannot refuse to take. Despite that, we have been able to manage them, and we have not yet returned any vehicles. With 6 or 7 of them running right now, we have almost taken 2,500 trucks in these plants and treated almost 5 mld of waste. And I'll ask my team to change this. It's 99% in the primary treatment itself. We are removing. So our incoming BOD average has been always been around 15 to 20,000 BOD. which we reduce it immediately by geobag to 95% or more. So this is a challenge that this geotube can handle, and it promises me to do that. So we have, as it says, that we have 8 plants in operation, 50,000 plus kiloliters have been treated, 5,000, sorry. And effluent, which we have used, is 3,500, which we used it completely into our garden. We don't buy any water from outside. And 150 tons of the biosolid has been distributed and recovered. So efficiency, it's very clear. COD is definitely less than 50. BOD is less than 20. Why we are saying this? Because the SBR is recently installed in one of the plant where we are trying to bring it down to 10, but most probably we'll succeed in doing that. And TS is 1%, SS is less than 50, and pH is maintained at 6.5 to 8. Of course, we have done a lot of tests, we have done a lot of studies, and a lot of visitors we have got across India and abroad visiting our plants. And we have a lovely plant in Bodopal, Hyderabad, which is very, very close to the city and beautifully running. So just to give about the company, we are a public limited for-profit social enterprise providing sanitation solutions to one and all. And of course, we call ourselves as an integrated sanitation solution provider, from the containment to the reuse or resale of the fecal sludge solids. We have been doing it. We were incorporated in 31st August 2012 in Hyderabad. Of course, rightly said, I'm the founder, but definitely we have a lot of team members who help me do all this. We have been a member in many of these recognized global organizations, and some of our directors have been part of these organizations, taking them to the next level, and of course giving a lot of presentation across. We have 900 employees pan-India, because we do a lot of business with Indian Railways. We have offices, of course, in Hyderabad now, and we have 6 regional offices across India. We are a public listed company and are trading. These are some of our board members. I will not go. And that's it from my side. Thank you so much. You're free if you can ask me some questions.
Yeah. Thank you so much, Namitaji. There are a few questions. Of course, I would take a few of the questions, and then later on I would request you, to take up the questions. One of the questions was, which has come up very prominently in the chat box, is, can the bag be reused again? Or is it a one-time use?
Yes, that's the only challenge we have. Yes, bag is only one-time use, because it has a thermodynamic pressure involved. So once we punctured the bag, the pressure is not, what do I say? Pressure is not available, or right? It does not work that way. So bag is not reusable, but it is resaleable because of its grade PP5, and it is reused and recycled. Also some of our bags have been used for what is it called? Rainwater harvesting. So it is used as a liner.
So is it like, there's another question related to that of the bag, is how is this manufactured, or where do you procure it from?
Yes, so it is a company called Tenkate, where we have tied up with them, and they have been supplying us with this technology and the bags. We have it in stock and in Hyderabad, and we are stocking this stuff. So anytime 100 bags are available with me. And there are many other manufacturers locally, but due to the technological advancement and the quality which we were looking at, we went with this company. They have an office in India also. So that's supply chain not a problem.
The other part of the question with this bag, and that will be the last question on the bag only, will the bag ever get clogged during the time of operation?
We have almost used 25 to 30 bags, and we have seen that if the process, the way the process is maintained, if it doesn't get clogged so easily. It's quite a tough nut to crack, actually. It works perfectly.
So there were few questions and a few more questions. One is on the pathogen removal system, how the pathogen removal is done in the system. There's a question on the land requirement land required for the system. And the last question I would take is the cost too high at every time we need to change it, this bag?
So I'll take the first question about the land requirement. Land requirement is there. The depends. So I said very clearly early that this system is very cost effective and economical for smaller units. When the volume increases, it might not be that efficient. So for ULBs and the smaller where you want to treat as low as 3 KLD to 50 KLD, this is very, very economical. If I go to the next point of that, how economical it is, so we have to compare with the other costs. So now if I give you the cost of these, what we're running almost 8 plants now. We deploy only 1 or 2 people on board because the 2 people is that one is my security guard and one is the operator. So this whole plant can run by 1 person. Second thing is that electricity is a very big cost, which is absolutely nothing in this. So each plant I think I'm paying 3,000 or 4,000 maximum. So so if you compare that, and the bag cost is around like somewhere between there are 3 sizes in that. So one is 12 meter cube bag, then we have a 20 meter cube bag, and then we have 27 meter cube bag. So 3 bags we are deployed at 10 KLD, 20 KLD, and 25 KLD, like something like that. So we have 3 sizes and 3 different things. So we have seen that the cost comparison to this and this is very different. So for example, roughly 20,000 or 22,000 is the cost of the smallest bag. If we use that 2 and we just deploy 1%, definitely it's still cheaper. It is still cheaper.
And the last question I would take, and then later on I would request you, there are several other questions in the chat box if you could answer them later. So one question I would take, I find this question very interesting, is does the efficiency depend on the surrounding environment like temperature or humidity?
No, that's the USP. Nothing. It's just a simple process where, yes, so there is only one thing that can tell when it's a little rainy, the bag takes longer time, or winter takes a little longer time to open up. That's it. So, but there is no change and it doesn't affect the environment at all. It's quietly sitting there on the floor doing its job. So that's one thing. And you also asked me about the pathogen removal.
Pathogen removal, yes.
Yes, that's a very important question. So to let all of you know that when I say 99% reduction in organic load, so also pathogen is also removed because we're removing all the solids. Imagine a BOD of 50, 20, 25, 30, and it comes down drastically to 99%. Definitely most of the pathogen and solids are held back inside the bag. And when over the period of time the bag is left to decompose or left to dry, slow and steady, the pathogen decrease because there is no food for them to eat. So they decrease over time. So we keep that is what we have understood and we have observed in all our tests. So that happens. And the water which comes out, definitely we are going for an aerobic treatment also. So the BOD load that comes out from this is nearly 150. So the maximum is 150 or maybe 170 sometime, but most of it is in the range of 120 and 100. So treating a BOD load of 120 or 150 is much easier than even treating like a load of 250 and 3. So it makes our work much easier because the BOD loads are almost standard in most of the load every day. So there is no variability at all. After the geo bag, there is no variability. We can control the whole system. But before the bag, the water is pumped, there is so much of variability. Sometimes I get a BOD of 10, sometimes 50, sometimes 1 lakh, sometimes 13,000. How do we manage that system? So that was the challenge that when we were designing the system, we had to address too.
So yeah, we must say that this is from your experience, we can make out that it's a kind of a very robust system where it can take up a wide range of the sludge load, carrying the organic load. Thank you so much. You can take on the other questions in the chat box and you can answer them. And I would request you to stay on with us. Our next speaker for the day, I would welcome Professor Shrikant Mutnare from BITS Goa campus. Sir, are you there? Yeah, sure. Please, sir. Pull on your slides and
thank you.
Sir.
So I'm just sharing my screen, just a minute. Okay. Good evening, everyone. Hope you can see my slides.
Yes,
Can
we
you?
can.
Yeah. So I'm Shrikant Muknuri. So I'm actually professor at BITS Pilani, Goa. But we always believe in taking the work to the land. So this is my startup, Backtreat Environmental Solutions. And we focus on wastewater treatment and anaerobic digestion, and majorly on resource recovery from septage. So we started this in 2015. As I said, myself, Shrikant, and Anusuya, we started this startup, and focus is mostly on the resource recovery from wastewater. And so we know the general numbers, like 70% of wastewater generated is untreated in India. So you need a solution for that. And we need not go the classical way of setting up the treatment plants, which uses energy and then nothing is recovered out of it. Rather, on a positive note, that the India is going with large number of FSTPs, which could be a different type of treatment plants, which focuses on the resource recovery. So why resource recovery is possible from wastewater is because of these numbers, what is there on your screen. Like, as you could see, there is urine and feces in the wastewater, and that has high percentages of NPK in it, and of course carbon in it, which is the natural requirements in a fertilizer. And when you treat that water, you have a source of water for reuse as well. Now, urine is rich in nitrogen and of course phosphorus and potassium, as well as the feces. And that comes in the wastewater, which is the focus of our work is to trap them as nutrients. Now, our way of producing manure is a little different. So it's a better quality manure than the regular organic manure. And we follow the principle of terra preta, which means black soil. And the way it was adapted in Amazon regions, on the right side figure, you could see that two adjacent lands are entirely different. One is highly fertile, the dark colored one, and the other light colored one, not fertile, even though it is in the same region. Now, when people looked at what is done in those days, like carbon dating and other analysis, scientists found that the way the waste was disposed in the Amazon region was different, and they bring in some additives into it. All the waste was added into in a particular manner, including fecal matter, including dead bodies, including organic waste. Everything was dumped in one area. Then they brought in some broken earthenware and ceramic units, and some bacterial cultures were also found in that. So we follow the same method of terra preta production, and that's why ours is called as the terra preta way of resource recovery from septage. And we consciously took a decision of not using electricity or any type of running motor, etc., because we wanted the system to work in any conditions, and we rely mostly on the gravity base. So the honeysucker or the the septic tanker comes in, they pour it in unplanted drying bed, the liquid and solids are separated, then we go in for a sort of a fermentation, which we optimized, and then we go, and post optimization, we go in for vermicomposting. And then we do some additives part, and then we make it a rich compost. I will show you the video of how it is done. And we follow how this terra preta quality is. We follow in terms of the different parameters to match with the fertilizer control order, as well as we look for the heavy metals in it. So we match that all the parameters matches with the fertilizer control order, and this is how it looks. This is a plant which manages one septic tanker per day, which is 8,000 liters per day. We have been operating this since 2 years, every day one septic tanker. So these separates and the solids are composted in these black color sheets. What you see is the composting bins underneath. And the video was taken during the rainy season. That's why you see the covers hanging. And so these are the composting bins. And those packed bags with the compost that is there. And this is a unit where the end product compost is sieved and bagged. And yeah, and behind these are the composting bins. And this is the vertical wetland which treats the water. So our wetland system has an advantage that it occupies lesser area compared to the other wetlands because it's an in-house developed vertical flow constructed wetland compared to the horizontal systems. It occupies less area. Then we look at the different parameters and we see that it matches the FCO order. For example, here if you see the pH is low, because of that your potash is low. So then we go in for an addition of ash into it, so to bring in the potash into it, and which will adjust the pH as well. And so the cost economics is about 5 rupees of compost production. And yeah, so the COD parameters are well within the discharge standards, and the coliforms that are found towards the end, we do hypochlorite addition towards the end, but we modified that according to the situations. Like we integrated in one of the condition, we integrated a UV disinfection system. In some cases, we have integrated electrochemical based disinfection system. And here in this case, we rely on the hypochlorite system. So we did further studies. All these are BIRAC sponsored ones. We are into the field now. And what we have done is we tested the compost that is produced. As I said, like we have been operating that for now almost 2 years, and we put whatever, and every day 8,000 liters of septic tanker content is processed, in which we get roughly about 300 to 500 kgs of manure. So we tested it on different plants. One is chili, as you could see. We tested it on chili. Then our terra preta, the middle one, you could see that performs better in comparison to chemical fertilizers or farmers' practice. Then we tested it on brinjal, which is almost, you could say, with the standard deviation part at par with the chemical fertilizers or with the farmers' practice. Then we tested it on paddy. And paddy, again, it matches with the farmers' practice or chemical fertilizers. Then, yeah, so we did this crop studies as well with our manure. We constantly monitor the manure quality. And now we scaled it up to manage 15 septic tankers per day in another municipal council, which in Goa, which is Bicholi Municipal Council, right? We can install this anywhere. And so this is the inauguration of our 15 septic tanker per day unit with Bicholim Council. And let's see, this is, yeah. So that's the whole unit. And let's see this part. So that's the 15 septic tankers on 90 to 120 cubic meters per day unit. So this whole area is Bicholim Council's municipal solid waste treatment plant, and they gave us space there. And yeah, so we are using that space for our treatment unit. So the septic tanker comes. So they discharge in these are the unplanted drying beds. And the green color, you can see the wetlands. So after separation of solids and liquids, the water gets treated in the wetland, and then it goes further. See, this black color is the solids, and the plants treat their water, and then there is a collection tank of water. Yeah, so thank you. So that's the gist of what we do with the fecal sludge management, and I'll be happy to take questions.
There's a question from Mr. Nagendra Singh. Nagendra ji, can you open your mic and put up the question?
Thank you. Just I was trying to understand that retention period that you have put a separate tank to separate solid and liquid. So what is the retention period for one?
Yeah, so it's so we don't want to lose the nutrients. So our retention time is less than 24 hours because we don't want to use the unplanted drying beds as a drying bed. Our intention is not to lose the nutrients. We want the nutrients. So the free water that is present in fecal sludge is what we remove it. I would say the solids are still some sort of a slurries or more of solids, but it's concentrated solids, so that the nutrients are. We have tested like different days as well. Like for example, typically in an unplanted drying bed, you keep it for 3 to 5 days, where you get the solid cakes. But then when we use that, we lose the nutrients, and it's a wastage. So we optimized it to keep it less than 24 hours. And then we use that so that we retain enough amount of nutrients in it.
And what is the retention period for the liquid treatment, the wetland?
Sorry?
Retention period of the wetland, that plant.
Yeah, wetland is immediate. Like what happens in a wetland system is it acts like a filtration system. You pour the water, so that's where the organic loading design plays a bigger role. You pour the water, it acts like a filtration system that everything will come out. Right? But the design or the organic loading design is in such a way that in next time when you're going to pour in, before that time, that is 24 hours, the waste that is trapped inside should degrade. Of course, it degrades because of the aerobic value. So if you ask in terms of the retention time, I would say 24 hours, but as soon as the water flows into it, it gets filtered and comes out. But then the design should be carefully done that it doesn't clog the system, because you can't put one septic tanker or 10 septic tankers in the same unit. For a few days it will work, but then it will clog. That's where the design is very critical of what should be the size, etc.
And it's a completely gravity based, right?
It's totally gravity based. We took a very conscious decision from day one when we had put a 1 septic tanker unit per day, although the power, everything was available on site, but it was a conscious decision to avoid that because we want to have a system which doesn't use power. And already the septic tanker brings in, so you have enough force to pump it. So even our 15 septic tankers per day unit does not require power.
Thank you. Nagendra ji, there are other participants who may have questions, please. If there are any other participants who have any questions regarding this, or otherwise, I would ask Mr. Nagendra to please put in your questions in the chat box, and Professor Mutnuri, can you take up in the questions? Stay with us along and then take up the questions in the chat box, please. Thank you. Can I invite Mr. Srinivas Rao from Meliorate to put up his slide deck and take on the dais to talk. We have Mr. Rao.
Yes, sir. Good evening.
Please, yeah.
Good evening, sir. Good evening, everybody. I'm Srinivas Rao. Sir has explained me about, I think I have got a proper introduction previously. So without wasting any time, I just going into this presentation. So this is my So company is Meliorat Engineers Private Limited. For last 15 years, you're into water and wastewater treatment. Mostly we're working for the pharma and other chemical industry.
So we
Yes.
can't see your presentation. I don't know if you're sharing it.
Yeah,
Is-
wait. Wait a minute, ma'am, wait a minute. Can you share for me, because I'm not getting this screen sharing for this.
Okay, so
Try.
there is a green colored option down share screen. If not, I can also share.
I'm not getting on my this thing.
Okay,
Yeah.
okay. I'll share it. Just give me a second.
Right.
Is it visible for you?
Yeah, Jyotsna.
Am I audible, ma'am?
Yes, sir. Yes, you are
Yes,
audible.
you are audible.
Please go ahead.
Right. Thank you. Yes, right. About our company, I just explained you previously that we are into water and wastewater treatment. For last 15 years, we were working for this wastewater treatment. We implemented a lot of innovations and we bring a lot of technology from abroad, even mostly from Israel and US. So that was we were working with the pharmaceutical industries there for their zero liquidity charge systems and for other applications like energy efficient systems, energy recovery systems. Likewise, when we are into ETPs and STPs, when coming to the FSTPs, we find the motto that the priority pyramid I explained. I think, ma'am, you can just go down into this next slides. So you just pass on. Just we'll go to directly to that and pass on, ma'am. And again, one more, and one more, one more. No, the go up. Somewhere we miss. Okay.
I guess the previous slide to this is the one where you should be beginning.
Oh,
Right
no,
slide.
sir. So I explained something in the entire this flow diagram and the process flow was mentioned somewhere. Go up, ma'am. Go up. So somewhere. No. No problem. I'll explain, sir. I explain. No problem. I think this is not the one.
Can you share the presentation, sir? Maybe you can go next. In the meantime, we can have the next speaker, Mr. Anand.
Yeah,
and then
we
we can
would
sort it
call
out in
up-
the meantime.
Yeah,
Yeah,
pull down the
please.
slides. Pull down the slides. Mr. Anand, from Dynary Engineering, I would ask you to pull up your slides and then speak up.
Hi, sir. Good evening. Thank you very much. Let me just share my presentation. Jyotsna ma'am, you have, right, like my presentation? I think you can share that. Yeah, I think this will do. Thank you very much. I kept it very simple and straight. I represent Dynary Engineering Private Limited. I'm the promoter and director of the company. Dynary Engineering has been engaged in solar power plant, wastewater treatment. These two are the predominant businesses which we have been working. Coming to the FSTP, what I found, when we started working on FSTP treatment plants, I found there are certain challenges So like qualitative and quantitative loading, they were not consistent. Sometimes high BOD, low BOD, and sometimes 100% water, sometimes no water. Few weeks there is no water, and again suddenly it comes water. So this is how there is inconsistent in terms of loading. Due to that, anaerobic and aerobic system were badly affected. We couldn't able to maintain the consistent flow. So every time we were having problems in terms of maintaining the bacteria count and all. Every time there was shock loading. So this was failing all the time. And one more challenge is this has a very high solids. So once we take the sludge decant, so separating solids and liquid was always been a challenge. It requires very high HRT as well. In the anaerobic treatment, gases like methane and other gases were emitting, and there was a lot of norms from the pollution control board. If we are emitting gases, so the kind of compliances that we have to follow was quite difficult at that time. At the same time, it required high HRT, means high footprint. Cost was incurring high. To maintain such plants, I was requiring highly skilled manpower. Mosquito breeding and smell was another challenge. So to counter all this challenge, so we came with a solution, that is screw press dewatering machine followed by a electrocoagulation. This had helped me to treat the sludge immediately, and it can able to handle a wide range of qualitative and quantitative loadings. If there is no load, no problem. After 1 week, if I receive a tanker, I can just switch on the button and I can start doing the treatment. So that's how it is. If the BOD, if the organic content is high, low, absolutely no problem, because it has got nothing to do with the bacteria initially. So that has really solved bigger problems. I require very less footprints, and in the entire treatment process, we are not generating any kind of gases. We are also integrating the entire system with the solar and wind, renewable energy. That is helping us to make the whole system as independent of power and grid. The treatment is completely green because we are not emitting any gases. It is cost effective, and at the same time, I don't require really highly skilled manpower to operate such plant. And ultimately, no smell in the plant, and the treatment can be done under a clean and green environment. This is what we came with the solution to execute to achieve this. Next slide, ma'am. To achieve this, the process what we followed was like a screw press. Ma'am, next one. Process flow, I think that is the previous one. Okay, no problem. So like this is a screw press where we can feed the sludge inlet. You can see there is a vent nozzle, the sludge inlet. From there, the entire sludge, it can we can take it from there, and we can separate solids and liquids. There is a filtrate outlet and there is a sludge outlet. These are the two outlets. Sludge outlets, solids comes out from that point, and and from the filtrate outlet, liquid comes out from that point. Next slide, ma'am. So the features are like we can start the treatment immediately after the decant. Solid liquid separation can take place instantly. All discrete particles which are present can be removed immediately, the same day, the same hour. We have been removing that. Whatever solids that comes out of the dewatering machine, it has 40 to 75% moisture, and due to the less moisture, drying can be faster. It helps the pasteurization, but to kill all the pathogens and eliminate the helminthics. It requires very less power, and we can operate such machine 24/7. To operate such machine, highly skilled manpower is not required. No smell is there, and at the same time, it can be treated without any gases, or there's no emission of gases. Next one. And after that, there is an electrocoagulation system. Next. So the water which comes out of the dewatering machine, that water goes into electrocoagulation. So that water is already free from all the discrete particles. The only constituent those are present in the wastewater were the constituents which are very micro level, and they have a bond with the water. So for those constituents, electrocoagulation helps in breaking the bond and separating all those suspended solids which we cannot see from the naked eye through the electrocoagulations. What happens is, here we have two different kind of electroplates. We provide DC supply to the plates, which leads to the forms the ionization within the water. Due to these ionizations, the release of metallic ion and the electrons, these react with the constituents, and that breaks the bond with the wastewater. This the moment it breaks the bond, so it start becoming it start coagulating. And with respect to its density, if it has less density, it floats over the surface. If it has high density, it's just precipitate and form a sludge at the bottom of the tank. So we have a mechanism to remove the flock and the sludge. We can drain these two things parallelly and take those solids into the first tank so that it can go through the dewatering machine again. And whatever water that comes out of this electrocoagulation, that water is free from mostly like all solids. Next one. So the features, if I talk about the features, like I already mentioned, the treatment starts in situ, and at the same time, after dewatering machine, immediately the water can go into the electrocoagulation system, and treatment can start. It breaks the bonds between the constituent and the pollutants and the water. It kills all the pathogens. The water comes out of the AC because we are giving potential, DC potential to the water. So it kills all the pathogens. We have a provision to drain the flocks and the precipitates, so that the entire solids can bring back to the first tank. High HO, COD, BOD, TSS, nitrogen, and everything can be treated conveniently. It is completely independent of shock loads. No smell during the treatment. It has a wide range of applications. Like we can use medical waste liquid, industrial waste liquid, along with the fecal sludge. So we are the one who treated fecal sludge with the electrocoagulation. This technology is very old. It is already existing in the industry. Mostly they have been using in the medical and industry applications. We are used for the fecal sludge applications. We have made certain modification and upgradation that has really giving fantastic results. This system can also be integrated with the IoT, which helps in terms of monitoring the parameters and controlling the flow. Next one. This is how we have seen the treatment. This is another application. It is not for fecal sludge, but even dye application also we have seen the results. Next, ma'am. This is how a smaller one looks like this, little higher capacity. Next, ma'am. This system can treat very small, very compact. This can treat up to 1 cubic meter per hour. Next, ma'am. This can treat up to 3 to 4 cubic meter per hour. Next one. Yeah, this is all about electrocoagulation and dewatering machine. And after electrocoagulation, water to build the confidence, we have a contingency in all our plants. With MBBR plant, which I have not displayed since it is known to everyone. After MBBR, the water passes through carbon filtration and sand filtration. Again, we have a UV. This is additional disinfection of the water. And we have been operating these plants in the various places like Khammam, Nalgonda, Aiza, Gadwal, Mahbubnagar, Palamner. So everywhere we have been experiencing a very good result. And all solids which is being treated in the pasteurization, we have seen they were completely free from pathogens and helminthics. Right now, whatever solids that we have been producing, a municipality is taking them and using them for their local plantation. Whatever water that is comes out of it, we are using in-house gardening purposes. I hope I am clear on electrocoagulation and dewatering machine. Please let me know if there are any queries. Thank you.
Thank you, Mr. Anand. There is a question from Mr. Nagendra Singh.
Okay.
The question is, can this electroflocculation work on grey water to remove dissolved detergent and other cosmetic items used at the household level?
Yes, we have tested these two as well. So what we have seen is whatever that detergent and cosmetics is also been removed. We have tested that. We have test reports and all. So yes, it can be done.
And the next question to that is, what is the cost of treatment unit per KLD? And what is the O&M cost per KLD? Kind of a rough estimate if you could give.
Okay. Like, if we keep it very specific to the treatment, by not considering support infrastructure and all. So machine to machine, I'm talking about like maximum is like 3 lakhs, 3.5 lakhs per KL, max.
Thank you, Mr. Anand. Stay on with us. There would be questions coming up on the chat box, and I'm sure. And please keep on addressing while you listen to our other speakers. Jyotsna, are we ready with Srinivas sir's PPT?
Yeah, he sent me another one. I request Avinash to present. Yeah, thank you.
Yeah, thank you.
Srinivas sir, are you there?
Yes, sir. Yes, ma'am. Okay.
Yes.
Please, sir, go ahead.
Yeah. Thank you once again. Good evening once again, one and all. About the wastewater treatment, about the sewage treatment and everything, it was explained, and the technology was very innovative. We just wanted to bring in the new innovative technologies into FSTP side. Apart, not only for the treatment facility and the unit operation, and also the few things like we have implemented some automation to just ensure that everything should be properly monitored, should be properly controlled, and treatment is within the control. Like, we can't completely base trust on the operators who are working over there. That was IoT and other things we have implemented. Ma'am, you just keep going down so that
yeah, Avinash is handling the slides. So,
okay.
Avinash, you can go to the process.
Yeah. The initial slides all about our company. So this is about my introductions, what we did previously and everything. I just wanted to stick this presentation only to this, focusing on this FSTP, right? So this is about the thing, our abstract and everything. We know the BODs, CODs, and the pathogens, elements, everything has to be removed. But concept, how we design the system, we just wanted to keep the premises or operators and everybody very safe, even during the treatment as well. Because so there should not be any spillages, there should not be any leakages, and we just wanted to avoid any direct human contact with the untreated septic at any point of the treatment time. So that you keep and go up, please. Previous slide. Yes, this is the priority pyramid. What is it? So this pathogen removal is the highest priority, then the organic load reduction and the reuse of the streams, like the liquid and the solid stream, that we wanted to go for that. And go down to the next slide, sir. So we know about this. So this is the method we wanted to design. The spillage should not be there. It should be the proper design, and the technology should be innovative, and it should treat both the liquid and the solid stream, and both should be recyclable. Next slide, please. This is a P&ID system. So what are the unit operation we mentioned clearly? So initially there is a screen chamber, and we have a collection tank, and that after that we have a solid liquid separator, then liquid treatment, and then solid treatment, and filtration. Everything will be there. The flow diagram will be there. Just go down to the next slide, please. Okay. One more tick, sir. 2 more ticks, I guess. So everything will then connectivity will be completed. Okay. Yeah, then fine. keep here. So this is about a schematic flow diagram. There, when the septic tanker is coming, then the bar screen chamber, there, the floatable particles, everything will be removed, then a collection pit. And here our technology is very simple. We name it combined biological treatment, because we have a biological treatment as well as the solar drying for this decontamination of the sludge and solids likewise. So initially we have a primary treatment. In primary treatment, we remove this all the floatable particles. Then after that, we have a dewatering zone. This dewatering, here we are using a screw press. This is a multi-axial screw press. Here the solid and liquid will be separated. Solid is being taken into the solar drying area. Liquid is being treated in the MBBR treatment, because the space and everything is matter, so that for effective treatment of the liquid stream, we adapted the MBBR system. Here we have some MBBR media, we give aeration and bioactivity. After that, we have a filtration, AMF, ACF. Then after that, and in AMF, ACF, this is not just like the sand filter, it is the active media filter, so that to avoid the mud ball formation and this frequent choking of the filters can be avoided by using AMF. And after that, we have this PCR, photocatalytic oxidation reactor, for the disinfection of the liquid stream, because this water we wanted to recycle to the premises where the landscaping, the gardening is happening, so that the gardener who is working in the, so we want to keep this place for this knowledge center. Maybe people, visitors will come, and a lot of gardening activities will be taken place. This water is watering for the gardening, the flowers and everything. So that when the people touch, so with the bare hands, we just want to ensure that there is no bio potential for that water, so that we want to disinfect with using this photocatalytic oxidation reactor. This is simple. We are dosing a low concentration of the oxidant in presence of medium intensity radiation, and we have a catalyst inside, so that OH radical will generate that OH radicals, eradicate the pathogens and harmful bacteria, so that the water is useful for that. And then coming to the solid is taken into the drying zone. That there is a shade, you can see the drying unit. So entire drying unit is enclosed with 90% transmittivity polycarbonate sheet. So from there it is dried, and then after we have a decontamination unit, that is IR radiation unit. Then the dried sludge can be taken, used as the manure by co-composting, and directly we can use it by addition of a few things. Please go down to the next slide. So here, one more. So you can see here, this is like one more. The one more. Yeah, here. So when this atmospheric air enter into this drying zone, so because this polycarbonate sheet allows solar radiation, natural solar radiation into the drying zone, then that will heaten up by, that will be that will heat the air, atmospheric air. That air will be blown onto the sludge blanket which is on the floor of this thing, and we have a paddle dryer. That paddle dryer will spread entire the sludge uniformly during the on the floor of this drying zone, and it will expose the sludge to the atmospheric, this dried air, so that the drying will be speeden up, and the proper drying will be happen. The moisture content will be reduced properly, and after that you can go to the next slide. After that, this dried sludge is taken to the, you can see some videos here. So here, so how it will be happen like that, and again, sir. Now you can just go on even to the next slide. So that will be already explained. Yeah, here. Then after that we have even after moisture content removal, so there is a potential of helminthics and the pathogens, harmful pathogens. So we just wanted to make sure that eradication of the pathogens should be there, because so we wanted to make sure that people can take this and touch this dried sludge with the bare hands, so that that can be done by instantaneous radiation and the heat effect on the dried and pulverized this sludge, so that with a proper resistant time, so that all the pathogens can be eradicated. That dried sludge can be kept and we can use for any other manure applications. And go down, sir. Go down. One more slide. Go down. So this is a few of the for pictorial representation where some Kamareddy and Uppal in Hyderabad places where we have done this FSTPs, and one more slide. So these are for the few unit operations, the bar screen chambers and the electrical panel and the liquid treatment area and the sludge drying zone and the solid liquid separation for the different places, different, and go down, sir. Go down. So in our Uppal plant, the people visited and seen how the premises were maintaining, and the solid liquid treatment and the treated liquid and the treated solid will be recycled in-house to the garden, which we are maintaining there, and the water will be gardening. And so most predominantly the beauty of this system in Uppal and other places that we have adapted automation, because the PLC operation is there, and we can go with the DCS, but there we have a PLC and HMI, and the mostly IoT system, because to minimize the man interventions, so that without more manual intervention, we can control, we can monitor, and we can operate the plant from the remotely from anywhere in the world. That was the application of the IoT we are adapting for all the FSTPs and go downs. And go down. Go down. Thank you very much.
Thank you, Mr. Srinivas. There are some certain questions. I would take one or two questions. Like,
yes, sir.
There's a question from one of our Sri Lankan participants. What is the efficiency of decontamination of the IR unit? Is it better than heating the sludge? In any kind of a comparison you would like to speak about?
IR is simply radiation. So even if I tell you honestly,
let me complete the question. He has a continuation to that question. How small should be the sludge particle should be before decontamination? Will the heat be transferred to all parts of the sludge? What is the heat maintained in the IR heating system?
So exactly true. So it's a continuous process of unit operations. In drying zone, we have a different drying zones. So in a solar drying zone, after the last drying zone, and we have a pulverizing conveyors. And after drying, we pulverize it to the 2 to 5 mm, 5 to 6 mm diameter size pellets will be formed after this pulverize. That pellets we are taken into this IR radiation zone. IR radiation zone, this is a radiation, so simply radiation. We are not going beyond that hundreds of degrees temperature. No, sir. We are just going to up to below 100 degrees only. But what we are ensuring is that the residence time and instantaneous radiation, and it is penetrating through the core of that pellet. It is not possible in this regular solar drying and other drying processes, because we are keeping this in an enclosed equipment machine. There it will be passed on from this, it is conveyed into that enclosure. There we apply IR radiation. That radiation is penetrating into the core of that pellet, and we are giving the proper residence time, so that it is not every time we cannot go by the temperature. So temperature will be 100 degrees, but the sufficient time is not available that we cannot ensure that pathogens are eradicated. We are giving proper time, and we are recycling again and again, and we're keeping proper residence time inside the IR radiation, so that we are ensure that it is pathogens and all the the helminthics and all the harmful bacteria will be eradicated. That is it, sir.
There's one more question to that. Is the IR applied all around? I didn't get the question. Nagendraji, can you open your mic and speak about it?
Yes. So when I'm saying that, when we are saying that there is a conveyor belt, so maybe the radiation is applied only from the side or top. So how it is taken from all around? Because if the radiation is coming only from the top, maybe some of the side of that 6 mm or 5 mm pallet, maybe some part of it is untouched or not getting the infrared radiation.
Yes, sir. I got your point, sir. We are not doing openly this. We have a reactor for this IR radiation. We have a reactor. So there is a conveyor. It is taken into that IR radiation reactor. So So almost I'm not telling you that the 360 degrees we have IR radiation, but we don't have 360 degrees. At least 270 degrees we have IR radiation provision to penetrate through the pellets. That's what, because only it is on the surface, and we have a cylindrical type of IR radiation units will be there. It will be reflected again and again, because it is completely enclosed. We are not letting out any IR out of that reactor, that we are safely enclosing each and every. The radiation will be safe, and the radiation will be more effective on the sludge inside.
So so all the surfaces most likely getting the radiation, exposed
yes,
to the radiation.
Most of the 80% of the surface will be getting the radiation, because it is a dried sludge. We are taking the dried, mostly less than 10% moisture content sludge only to the IR radiation. So the pellets after pulverization, the pellets also have very lot of wide area inside it. You know about it, sir, because the sludge, organic sludge, having the lot of wide area. Because after this evaporation, after the drying of all the moisture content from the pellet, so lot of wide area, just like a charcoal, lot of wide area is available inside it. So what we are doing, we are just allowing all the radiation to penetrate into that wide areas, even to that corest of the core of that pellet, so that we can ensure. So the time, we are giving proper time, and we are giving proper access to the radiation to go and kill that pathogens inside it. Sir.
Thank you. Thank you so much, Mr. Srinivas. There's one more question. What is the average cost for treating 1 ton of the solids? Or I mean, Mr. Tilana, is it 1 ton of sludge or 1 ton of what you're trying to say? Sludge. Yeah.
So this for the operational and maintenance, you're asking for the capital investment. I just wanted to more precise. Is this for the capital, or is this for the O&M?
Mr. Tilana,
both you need. So the first thing, for the capital, it always depends on the capacity, because if it varies between 3 lakhs to 8 lakhs per KL of per ton of this sludge, based on this capacity. If I go bigger capacities, per KL treatment cost will be less for the capital investment. So generally, you know about it, because my pump, 10 KL pump, will not 10 times to the 1 KL pumping, just like electromechanical items and all the infrastructure. It always, sometimes it is not exponential, it is not proportionate either. So this is 3 lakhs to 8 lakhs in between per KL of treatment for the capital investment. Coming to the O&M operations, mostly what based on my experience, I have a 40 KL plant, I have a 30 KL plant. Per month, I'm getting expenditure inclusive of everything, the man, human resources, and the maintenance and the chemical cost, everything, 1.5 lakhs to 2 lakhs per month per a plant, whether it is a 40 KL, whether it is 60 KL. So if I go with 100 KL, something also almost similar to that. But the chemicals, we are not using much chemicals. We are using mostly depending on the natural energy resources like solar and other things. So if I take for 100 KL, if it is 2 lakhs per month, I need to calculate it. Hello?
So you're on mute. Can you got into mute?
Yeah. It is less than 2 lakhs rupees per month for it is O&M for the less than 100 KLD capacity plant. If it is 20 KLD, 30 KLD, will get maybe 1.5 lakhs per month. If it is 100 KLD, we'll get 2 lakhs rupees per month is the O&M expenditure. Am I audible?
Yes, you are. Sorry.
Yeah.
Yes, you are.
Right.
And thank you so much. Stay with us.
Yeah,
and there would be questions coming up on the chat box. Please take them on as we go on to our next speaker from Primove. We have Mr. Sushil Nikam to be speaking on behalf of Primove. Mr. Sushil, can you put up pull up your slides and then take on the device.
So your slides are still loading. Can you reshare it again? Yeah. You're on mute. Do you want us to share on your behalf?
Yeah, please.
Yeah, Avinash, please share.
Is it visible also?
Yeah.
Yes, it's visible. Go ahead.
Yeah. Good evening, everyone. I'm Sushil Nikam, presenting on behalf of Mr. Ajit Oak from TBF Environmental Solutions regarding this FSTP plant. Next slide, please. Yeah, so TBF has developed basically 3 products. One is Tiger Toilet, second is STP based on this vermi filtration, and FSTP again based on vermi filtration. It is a 100% natural technology. Next slide. So this may be the current practices of sludge disposal. Next one. This is the process flow diagram for the FSTP developed by TBF. This is the screening. First operation is the screening. After screening, collection tank. After collection tank, there is a series of anaerobic digester. Then sludge storage tank. After that, the heart of the technology is Tiger Biofilter 1. Here, the applied sludge gets percolated through the bed, natural bed. And the treated water applied to the Tiger Biofilter 2 bed. Sorry, last slide. Last one. Yeah. And from this second Tiger Biofilter, this treated water is collected again into the filter feed tank. Then filtration is there through PSF and ACF. And the last step is chlorination for disinfection. So here we can see 3 pumps are required, and this actual process takes place in this Tiger Biofilter, which is a natural process. This bed consists of gravel, then worms. So tiger worms is a specific species of the worms which is more efficient to digest human waste. So that is the heart of the system. Next slide, please. So the earthworms are naturally suited to process high organic loads, very rapid installation. It takes very small time for the installation. Capital costs are 15 to 20% cheaper than conventional one. The space requirement is much lower than conventional systems. No needs of chemicals other than hypochlorite for disinfection. Then very small electricity there, and the best part of this process is there is no sludge generation. No sludging part is there. No any mechanical equipment required for sludge processing and sludge disposal worms in the bed itself. And it can be it is converted into the vermicompost, which can be removed after few days or few months, and it can be used as a manure. So next slide. So the advantages of this technology, basically it is 100% natural, high energy saving, easy operation. Any unskilled worker can operate this. Area requirement is very minimum. Then one step process, rapidly treat the fecal sludge. Then vermicompost obtained is the byproduct. This is the vermicompost obtained, and these are the photographs of the inlet of the sludge up to the final outlet. So up till now, we have completed these projects. Some of the projects are ongoing. The capacity is handled, maximum capacity is installed are 32 kg, and the minimum is 5 KLD. So we have installed up to 32 KLD FSTP plants based on this technology all over the India. Next slide. These are some of our installations. These are the photographs of 10 KLD fecal sewage sludge treatment plant at Thrissur, Kerala. So we can see these are the beds. This is also a bed. This is filtration unit. Then this is the plant at Kalpetta. It is again a 10 KLD capacity. These are the samples, a photograph of samples. This is a series of 3 tanks, anaerobic sludge reactor. And this is again 10 KLD FSTP plant at Malkapur, Maharashtra. Next one. This technology is proposed by Department of Drinking Water and Sanitation for fecal sludge management plant using Swachh Bharat Kosh Fund. So we are doing the projects for the villages who are having funds under Swachh Bharat Kosh Fund all over the India. Next one. This technology is empaneled by Government of India, Ministry of Jal Shakti, and we can technology under Swachh Bharat Mission started for about 50 projects of FSTPs at different villages under this SBM.
So are you done with your session? We can't hear you.
Hello.
Hello.
Am I audible?
Yes, yes, now you are here.
Yeah.
So the house remains open for any questions.
This is the last slide.
Yeah. House remains open for any kind of questions the participants may have. Please. Nagendra Singh ji, how does the performance can be affected if we place normal worm or without worms?
In the initial stages, we have checked with different species of the worms, but we found this specific tiger worm species of the earthworm more effective to consume the human waste.
So suppose
the decomposition time will be more in case of other worms, so that plant capacity will be higher. Means sludge application rate will be less as compared to in case of these tiger worms. So basically, either there will be a big size of requirement of tiger biofilter beds, both the beds,
So this worm is different than what we use in the vermicomposting of the cow dung?
No. This is again different from what we use in the vermicomposting. This is a species identified which is efficient for consuming human waste, basically.
So this is especially developed by your agency and
in our lab we are developing
Just to intervene,
we are breeding these worms.
Can we pull down the slides and then have the discussion? Yeah, thank you. Yes, Professor Chari, may I welcome you and to carry on the discussion with all our concessionaires and presenters today.
So I think one of the questions, thank you very much. One of the questions Mr. Nagendra Singh asked, Namaskar sir, is these tiger worms, is it a sort of a patented one, or you have anybody can approach you? How does it work, sir?
Tiger worm is not a patented, it is a available species. It is not invented by us, but the technology and the design is patented.
The integration is sort of is yours. Okay. So thank you very much. It's a way of sort of bringing how mature the sector has become in a very short span of time. In the last 4 or 5 years, different thought leaders in the industry have come together, used different their own expertise to integrate different technology unit operations and then come up with a very localized, very practical solution. I think this is the best part of what you have seen and witnessed in the last 1.5 hours. You have a variety of gamut of solutions, starting from nature-based solutions, what you just heard, as well as very high advanced or mechanical systems, as you have seen, based on the size and configuration, availability of the land. We can configure these systems. The choice is available to all of you. And this whole purpose of today's conversation is to expose you to the choice of solutions that are available and the thought leaders in this region who can support not only India, but also Bangladesh, Nepal, and other places. That's the whole purpose of today's discussion. Now, one area, in fact, this morning I was coming from a meeting with the government of Telangana, actually, is the big concern that they have in any of these operations is the operation and maintenance. Because kahin projects aisa banate hain hum log, uske baad maintenance, sustainability of these issues is a big concern, both in terms of skill requirements as well as the cost. So I would just pick up a couple of points. I mean, I would ask 1 or 2 points from our eminent panel. How difficult or how easy to localize the operation and maintenance? So may I start with Namitaji? You know, you have set up a number of units. If you are around, can we sort of localize it by engaging self-help groups, get them to onboard them, and then they can in turn provide an O&M service? Is it doable, or what are the challenges that you have experienced or you continue to experience on the operation and maintenance front?
She's there, but ma'am, you are muted if you are speaking.
Hello.
Maybe yeah, she's there, sir. Maybe I'll check with her. Namita ma'am, you're on mute if you're speaking.
So can we ask Mr. Ajit? Ajit sir?
Ajit Saab nahi hai, sir. Unke representative Mr. Sushil.
Sorry. So can I ask you, sir, is this tiger biofilter, is it very difficult? They need you all the time, or can you localize it? For example, in Kerala, there's a very strong SHG groups. Can they operate themselves? Can the panchayat or municipality, can they operate themselves? You are
muted, sir. You are muted, sir. आप म्यूट में हैं सर, आप अपना स्पीक
yeah, sorry. Gram Panchayats can operate at their levels. We are now setting up these plants at village levels, and it is very simple to operate because the worms are adjusting their population based on the sludge composition or concentration of the sludge itself. It doesn't require any special attention, and the system is very easy. Means it's a hydraulic flow only after pumping. Then each and every material is locally available in any state of the India. Expect only these tiger worms. This can be supplied by us, but other material, which is the core of the technology, that is available across the India.
And is it, are these worms very sensitive towards input variation? For example, sometimes we get sludge of varying degree of concentration, varying degree of, certain cross contamination also we observed. How sensitive is your system?
Two things are there, sir. Now we are receiving sludge from various septic tanks. They collect into the vehicles and they put it to the plant. So quality of the sludge in each septic tank is different, means age of the sludge at the time of desludging. So it gets diluted, first part. Second part, first part of our system is the mixing chamber, having 1 day retention time. So in that 1 day, it gets homogenized, it gets mixed properly. So whatever sludge is going for the anaerobic digestion, it is a homogeneous one. So no shock loading, and it is a properly mixed sludge.
So you sort of reduce the shock load by creating a retention system and then keep it.
Yeah, because for anaerobic digestion, there is a requirement of retention. We have provided mixing chamber also.
Okay.
So uniform sludge is forwarded to the next tanks. Okay. Second thing, these worms are not sensitive to climate changes. Okay, means we have tested it up to, I think, 6 degrees.
Okay.
Temperature.
So, Professor Srikanth, I just wanted to check with you. Is your unit scalable from a small unit, maybe a cluster of households, to a big city where like Hyderabad or Bangalore, they want about 100 KLD facility or even more? Can it be scalable from any range to any range, or what are the limitations?
Yes, sir, it can be scaled up. Like, for example, we have demonstrated from 8,000 liters to 90 to 120 cubic meters per day. Means starting from 1 septic tanker to 15 septic tankers.
And can I combine both gray water and both night black and gray combined also can be done?
Yeah, it can be done. So that's an advantage as well, because your BOD to COD ratio will be adjusted without adding anything. So in that way, gray water and septic water or black water can be treated together as well.
So that probably answers Mr. Nagendra Singh's question in a way. Also the scalability issue, which many of us are concerned that these plants are viable only at a particular level. So I think that's good. So Mr. Anand, just wanted to check with you. Yours is a bit of high-end system. What is your experience in terms of, you have sort of introduced multiple technologies. You started with one, then you migrated to this. So what is the USP of your solution? What is the specialty of your solution?
Yes, sir. Like I experienced a wide range of processes. What I feel our USP is we can treat instantly. Same day the sludge comes in, and the same day we take out solids and liquids, and we can dispose the liquid same day. Solids will take 6 to 7 days time in order to dry it completely and eliminate pathogens and the helminthics. That is one part. Footprint is very less, and if we confine ourselves to the treatment, the installation is quite easy, simple. Anywhere we can deploy. irrespective of it is a crowdy place, that way. Now, in a coming days, I'm working on like how this system can be integrated with the solar and wind, so that it can become a completely power independent system, so that O&M cost comes down substantially. Highly skilled manpower is not required. Rigorous monitoring is not required. Plug and play kind of system is this. So this is what I feel the USP about our system, sir.
Thank you. So, Mr. Srinivas, are you there by any chance?
Yes, sir. Good evening.
Yeah.
Sir.
So
Yes,
good evening. Mr. Srinath, one of your the solutions that you offered, and I've seen, monitoring is very, very important. We all know. And you have sort of nicely integrated sensor technology, IoTs, at the process level as well as at the output level. In terms of process, how much is the energy consumption, what is the current performance of unit operations, as well as your output monitoring. So is this monitoring system, is it expensive, or for the benefit of our participants, this IoT based monitoring system, is it very expensive, or it can be integrated in right at the DPR level, and it can be embedded in when they are developing treatment systems?
It is not at all, sir. Not at all, because we are not changing any electromechanical items. So only the thing, so during the electrical control panel level, we have to take a few things like that. Just like IoT is coming to our households, the smart houses, that people are operating the lights and the doors, everything can be monitored and controlled nowadays. Similarly, unit operations, we can control it. But if you ask me for the parameters, it is a little difficult, because we can provide all the IoT access to the parameters. If you wanna sitting in CDMA ASCII, you want to check my Uppal plant, other plant, COD, or all the organic matter which is letting out to the atmosphere. I mean, the water bodies, you can check the COD, but we cannot afford, because the online TDS, I mean COD meters are costlier. Up to that, we can provide a provision that, so if somebody can provide me the COD meter, online COD meters, that everything can be done, sir. But incorporating IoT and the remote controlling and remote accessing is not a big deal, sir. We can happily, for the existing systems, we can incorporate it, definitely.
So thank you very much. And those who are coming to Hyderabad on Monday, I think it's Monday, I think you could see these systems live.
Tuesday, sir.
Tuesday. You can see the systems live. You can experience them, and you can see how monitoring systems can be nicely integrated in the treatment solution, so that one of the weak links in all these treatment systems is to make sure that they are monitored thoroughly, and often that's one of the weak areas. So an IoT system, costs are come down, so we can nicely integrate control as well as monitoring. Both can be sort of integrated in this, so you will experience and see some of them. Lastly, I just wanted to thank all of you. I think Namita ji is still there, or if she's there, then I would like to say hello to her and then ask a question. Otherwise, we will close the session. It's already exceeded the time. Thank all the speakers, panelists, for taking out their time, sharing their experiences. Friends, all I can say is that the first generation of fecal sludge treatment systems, they were all imported. In fact, we have also got one very fancy, expensive system. But in 3-4 years' time, we have bright minds, bright enterprise entrepreneurs here who could manage to integrate very frugal, very practical, relevant systems for the region, for the South Asia, and you can reach out to any one of them, and you can reach out to all of them for finding appropriate solutions based on your own conditions, based on your regulatory requirements, based on your cost, as well as the constraints in terms of land and other human resource requirements. I thank all of you. In fact, we also have startups and academicians like Dr. Srikanth and others who are phenomenally bringing research contribution to this. In fact, they have a fantastic lab also in Goa. So you can also take advantage of the monitoring sort of systems that they have. So this is a bright enterprise available to us, and we can take advantage of it and then put up these systems and at the earliest. So thank you very much, all of you, for joining us. Have a great weekend ahead. And